I'm Rayesh Uppal, founder of IDST. We bring you sharp insights and foresight on emerging tech, defense, and security. Let's dive in.
What if your phone, your car, or even the servers that run the world's AI could think at the speed of light, all while using a fraction of the power? Sounds like science fiction, right? Well, the future of computing may be about to make that a reality, thanks to something called in-memory photonic processors. And trust me, once you understand what's happening here, you'll see why this is a game changer not just for tech companies, but also for defense, communications, and even sustainability. I'm Rayesh Uppal, founder of HITOP. We bring you sharp insights and foresight on emerging tech, defense, and security. Let's dive in. For decades, our computers have been trapped by what's called the von Neumann bottleneck, the constant shuffling of data back and forth between memory and processors. It wastes time, it wastes power, and it limits how far we can scale our systems. But what if we could process data exactly where it's stored? That's the magic of in-memory computing. Now, add photonics, using light instead of electricity, and you get a system that can do trillions of operations per second, in parallel, with almost no latency. That's the power of light-based computing. One of the most exciting examples of this is the hypermultiplexed integrated tensor optical processor, or HITOP for short. Imagine an optical chip that doesn't just match today's best processors, but beats them by up to 100 times in both performance and energy efficiency. By harnessing hypermultiplexing, it performs massive tensor operations, the kind AI needs for deep learning, at lightning speed. And because it's built on integrated photonic circuits, it can be scaled down to chip-level devices that fit into existing systems. The civilian potential here is enormous. In AI, we are talking about training massive models in hours instead of weeks. For 6G networks, this could mean instant beamforming and real-time spectrum optimization, keeping millions of devices connected without lag. Data centers, those massive power-hungry buildings, could slash their electricity bills while handling more workloads than ever before. Even your everyday devices could run far more sophisticated AI locally, without draining their batteries. But let's not overlook the defense angle. The U.S. Defense Advanced Research Projects Agency, DARPA, is already funding work in this field, because the implications are huge. Think real-time battlefield decision-making, where AI can process incoming drone feeds, satellite imagery, and encrypted communications in seconds. Think about secure quantum-resistant encryption happening on the fly, or sensor networks that can adapt instantly to new threats without overwhelming the system. For military command and control, speed isn't just an advantage, it can mean the difference between success and failure. And here's something even more exciting, this isn't just theory. Prototypes are already demonstrating these capabilities. Research teams like the one led by Zaijian Chen at HITOP are working on compact, scalable photonic chips that integrate both memory and processing. They're proving that light-based computing can handle AI inference, high-speed signal processing, and even quantum-adjacent applications, all while sipping power compared to traditional processors. Of course, there are challenges. Manufacturing photonic chips at scale requires precision that pushes the limits of current fabrication techniques. Integrating them seamlessly with our existing electronic systems is another hurdle. And we need industry-wide software support to make the most of this hardware. But history has shown that when the potential is this great, innovation tends to find a way. So here's the bottom line, in-memory photonic processors like HITOP could be the foundation of the next computing revolution. Whether it's making our AI smarter, our networks faster, our military systems more capable, or our energy footprint smaller, the impact could be profound. And the race to master this technology, it's already underway. If you've ever wondered what the future of computing looks like, you might be looking at it right now. And it's moving at the speed of light.